Report on projected 50% reduction in space travel costs by 2027, transformative effects on aerospace, telecommunications, and defense industries. Date, February 10, 2025. Overview. By 2027, advancements in technology are expected to yield a significant 50% reduction in space travel costs, leading to transformative effects across the aerospace, telecommunications, and defense industries. This shift is anticipated due to increased competition, particularly from nations like China and India, substantial investments in space exploration, and the progress of NASA's Artemis missions. Key insights. 1. Projected growth across industries. The aerospace, telecommunications, and robotics sectors are projected to grow by approximately 50% by 2027, driven by investments in automation and space exploration. The aerospace robotics market alone was valued at $2.9 billion in 2023 and is expected to expand rapidly. The global space economy is forecasted to rise from $630 billion in 2023 to an estimated $1.8 trillion by 2035, primarily fueled by increased satellite demand, positioning services, and advancements in AI technology. 2. Technological advancements. The integration of automation and AI is crucial for this growth, enhancing manufacturing processes and significantly reducing costs. AI tools are streamlining the design and production of lightweight components, improving fuel efficiency and reducing emissions. Innovative technologies such as 3D printing and digital twins are expected to optimize production processes, enhancing efficiency and minimizing material waste. 3. Industry challenges. Despite strong demand, the aerospace sector is grappling with ongoing supply chain issues and workforce challenges. Labor shortages pose a significant barrier to meeting production goals, particularly in the context of increased military spending. Geopolitical tensions and pandemic-related disruptions are complicating supply chains, leading companies to extend the lifespan of existing aircraft and increasing demand for maintenance services. 4. Timeline of expected developments. 2024, increased demand across all aviation sectors, with commercial aircraft production rates anticipated to rise. However, supply chain delays could limit output. 2025, expected advancements in digital technologies and heightened investments in automation. The industry is likely to see a resurgence driven by ongoing demand for new aircraft and defense systems. 2027, the culmination of technological advancements and investments is projected to result in a 50% reduction in space travel costs, significantly reshaping the aerospace landscape. Common themes. Technological innovation. Most sources highlight the central role of technological advancements in driving growth and cost reductions across aerospace and defense sectors. Supply chain resilience. The necessity for improved supply chain management and workforce development is a recurring theme, underscoring the importance of strategic investments to mitigate risks. Variances between sources. Some sources emphasize the economic potential of reduced space travel costs, while others focus on specific technologies like AI and automation that will facilitate this change. There are slight differences in timelines and expected growth rates, with some sources projecting faster growth in 2025 than others. Detailed analysis. 1. Economic growth and industry dynamics. The anticipated growth in the aerospace, telecommunications, and robotics sectors reflects a broader trend of increased reliance on space technologies and the need for advanced communication systems. As countries like China and India ramp up their space exploration programs, competition is intensifying, prompting innovation and investment in these sectors. 2. Innovation and technological integration. Automation and AI will play pivotal roles in enhancing production efficiency and reducing operational costs. The application of AI in manufacturing processes allows for the optimization of resource allocation and the minimization of waste, which is critical for the sustainability of the aerospace industry. The use of technologies like 3D printing and digital twins not only facilitates the rapid prototyping of components but also enables manufacturers to create complex structures that were previously impractical, thereby enhancing overall product performance. 3. Challenges and obstacles. The aerospace industry is currently facing significant hurdles due to labor shortages and supply chain disruptions. The demand for skilled labor remains high, but the industry is struggling to attract and retain talent. This issue is compounded by the ongoing geopolitical tensions that affect supply chains on a global scale. To address these challenges, companies are increasingly investing in workforce training and development programs as well as exploring automation solutions to alleviate labor shortages. 4. Future projections. The timeline outlined for the aerospace and defense industries indicates a strong recovery trajectory with expectations for increased production rates and technological advancements leading up to 2027. The eventual reduction in space travel costs is expected to democratize access to space, enabling more players to enter the market and fostering greater competition. Conclusion. The projected 50% reduction in space travel costs by 2027 is set to significantly impact the aerospace, telecommunications, and defense industries. This transformation will arise from technological advancements, increased competition, and strategic investments. While challenges remain in workforce development and supply chain management, the overall outlook for these industries is positive, with substantial growth anticipated as innovations continue to unfold. The anticipated 50% reduction in space travel costs by 2027 is a pivotal projection that highlights several counterintuitive insights about how such a decrease may reshape various industries, particularly aerospace, telecommunications, and defense. Here are the key counterintuitive points drawn from the content provided. 1. Increased costs leading to lower prices. It may seem paradoxical that the aerospace industry, which has historically grappled with high operational and production costs, can achieve a 50% reduction in space travel expenses. This transformation is expected to result from advancements in automation, AI, and manufacturing technologies, which will streamline production processes and reduce material waste. The idea that costs can go down while investment in technology and infrastructure increases challenges traditional economic assumptions about cost structures in high-tech industries. 2. Supply chain issues amidst growth. While the aerospace sector is projected to expand significantly with increased demand for aircraft and services, it faces ongoing challenges with workforce shortages and supply chain disruptions. This juxtaposition of strong demand and significant operational challenges is counterintuitive. One might expect that higher demand would naturally lead to increased production capacity. However, the reality is that the industry must navigate complex global supply chains and labor markets where shortages can stifle growth even in booming sectors. 3. Positive outlook despite adversity. The projection of a booming space economy, growing from $630 billion in 2023 to an estimated $1.8 trillion by 2035, exists alongside significant geopolitical tensions and economic challenges. The expectation that a thriving market can emerge from a backdrop of uncertainty and disruption contradicts the common narrative that stability is a prerequisite for growth. This suggests that industries can thrive even when facing external pressures driven by innovation and competition. 4. Competition from non-traditional players. The rise of competition from countries like China and India is presented as a driving force behind technological advancements and cost reductions. Traditionally, competition is thought to come primarily from established players in an industry. However, the landscape of space exploration is changing, with new entrants driving innovation and efficiency, which may lead to lower costs and spur growth in the sector as a whole. This shift disrupts the conventional wisdom that established entities are the primary drivers of industry advancements. 5. The role of digital transformation. The expectation that digital transformation, including the incorporation of AI and automation, will play a critical role in reducing costs and enhancing efficiency, challenges the notion that high-tech solutions are inherently expensive. The integration of advanced technologies is often viewed as a cost burden, however, in this context, it is seen as a necessary investment that ultimately leads to substantial cost savings and operational efficiencies. 6. Sustainability as a competitive advantage. The increasing focus on sustainability and green technologies in aerospace and defense represents a departure from the traditional view that prioritizes cost or performance above all else. The expectation that companies will invest in sustainable practices, like electric flight technology and 3D printing to minimize waste, reveals a counterintuitive perspective where environmental responsibility aligns with economic viability, suggesting that sustainable practices can also enhance profitability. 7. Democratization of space. The notion that lower barriers to entry will enable a wider range of players to participate in the space economy is contrary to the traditional view that high costs and technical barriers restrict access to large established firms. As costs decrease, smaller firms and startups can enter the market, leading to increased innovation and competition, which could reshape the industry dynamics significantly. 8. Labor demand amid automation. The expectation that automation will reduce the need for skilled labor contradicts the reality that as industries evolve, there will be a greater demand for skilled workers to manage and maintain these advanced technologies. This paradox highlights the complexity of the workforce landscape, where automation can lead to job creation in new areas, even as traditional roles may diminish. 9. Long-term backlogs. Despite demand, the aerospace industry's substantial backlogs for aircraft orders despite strong demand illustrate a counterintuitive scenario. The expectation that backlogs would lead to increased production does not hold true due to supply chain constraints and production challenges. This highlights the complexity of supply chain management and production planning in a rapidly evolving market. 10. Investment versus immediate returns. The emphasis on long-term investments in technology, workforce development, and supply chain resilience contrasts with the expectation of immediate returns. Companies are increasingly recognizing that fostering innovation and enhancing capabilities takes time and resources, which may not yield quick results but are essential for sustained growth and competitiveness in the future. In summary, the projected reduction in space travel costs presents a series of counterintuitive insights that challenge conventional economic narratives. The interplay of technological advancement, supply chain dynamics, and global competition creates a complex landscape where traditional assumptions about growth, cost, and competition are being redefined. The report discussing the projected 50% reduction in space travel costs by 2027 highlights several significant insights that may not receive the attention they deserve. Here are the critical overlooked aspects and their significance. 1. Global competition and strategic investments. The role of increased competition, particularly from China and India, is crucial for understanding the dynamics of the aerospace industry. While many may focus solely on the technological advancements driving cost reductions, the competitive pressure from these nations is a significant catalyst for innovation and investment in the space sector. Significance. As countries vie for dominance in space exploration, the U.S. may need to re-evaluate its own strategies and investments. This competition could lead to faster advancements and a more aggressive pursuit of new technologies that could redefine global partnerships and economic alliances in space. 2. Impact on emerging markets. The report emphasizes the expected growth of the space economy from $630 billion to $1.8 trillion by 2035. What is often overlooked is how this growth will impact emerging markets and their capabilities to participate in space-related activities. Significance. The democratization of space access can open up new avenues for developing countries, allowing them to leverage satellite technology for telecommunications, agriculture, and disaster management. This could lead to a more equitable distribution of technological advancements and resources. 3. Supply chain vulnerabilities. The ongoing supply chain challenges, while mentioned, often receive less focus compared to technological advancements. Issues such as part shortages and workforce challenges are critical to the industry's ability to meet projected growth. Significance. Understanding these vulnerabilities is essential for stakeholders to develop robust supply chain strategies. Companies that can navigate these challenges through better workforce training and resilient supply practices will have a competitive advantage, making this an area ripe for investment and innovation. 4. Workforce development and labor shortages. The report highlights workforce shortages as a significant barrier to meeting production targets. However, the specifics of how companies plan to tackle this issue, such as through automation or apprenticeships, can easily be overlooked. Significance: the ability of companies to attract, train, and retain talent will shape the industry's future. Investing in workforce development not only addresses immediate shortages but also ensures a pipeline of skilled workers capable of handling increasingly complex aerospace technologies. 5. Technological integration. While the report discusses technologies like AI and automation, the broader implications of integrating these technologies into existing systems may not be fully appreciated. For instance, how AI can optimize supply chain management and operational efficiency is a significant consideration. Significance: the integration of AI and other digital technologies can result in transformative shifts in how aerospace companies operate. By embracing these advancements, companies can enhance productivity, reduce costs, and improve decision-making processes, positioning themselves better in a competitive market. 6. Environmental considerations. The report mentions the potential for technological advancements to reduce emissions and improve fuel efficiency. However, the broader implications of these advancements for global sustainability efforts are often overlooked. Significance: as the aerospace industry works towards reducing its carbon footprint, it aligns with global sustainability goals. This not only enhances the industry's reputation but also opens new markets for eco-friendly technologies and solutions, creating potential revenue streams beyond traditional aerospace applications. 7. Geopolitical implications. The geopolitical tensions affecting the aerospace and defense sectors are critical but may not receive adequate attention. As nations ramp up their space capabilities, the implications for international relations and security are profound. Significance: countries that lead in space technology may gain significant strategic advantages, influencing global power dynamics. This could lead to new alliances or conflicts, making it essential for policymakers and industry leaders to navigate these complexities carefully. 8. Regulatory landscape. The evolving regulatory environment surrounding aerospace, particularly in the context of defense and commercial space activities, is often overlooked. As the industry grows, so too will the need for effective regulations to ensure safety and security. Significance: companies that proactively engage with regulatory bodies and adapt to emerging policies will be better positioned to capitalize on new opportunities. Understanding and influencing the regulatory landscape can provide a competitive edge. 9. Innovation ecosystem. The report notes the significant role of private sector involvement in space exploration. However, the nuances of how collaboration between startups, established firms, and governments can enhance innovation may not be fully explored. Significance: fostering a robust innovation ecosystem can lead to breakthroughs that drive cost reductions and enhance capabilities. Companies that engage in partnerships and collaborative research will likely benefit from shared knowledge and resources, accelerating their growth. 10. Market segmentation. The report highlights growth across various sectors. Yet the specific market segments that will benefit most from reduced space travel costs are not detailed. Understanding which areas within aerospace, telecommunications, and defense will see the most significant growth can be crucial for investment decisions. Significance: identifying high-growth segments allows companies to tailor their strategies, focus resources, and capitalize on emerging trends, leading to better returns on investment. In summary, the report offers a wealth of insights into the projected reduction in space travel costs and its implications, but it is essential to delve deeper into the aspects that are often glossed over. Understanding the competitive landscape, workforce challenges, technological integration, and geopolitical implications will provide a more comprehensive view of the transformative effects on industries involved in aerospace, telecommunications, and defense. Addressing these overlooked areas will be crucial for stakeholders aiming to navigate the rapidly evolving landscape of space exploration and technology. 1. Projected growth across industries. The anticipated 50% reduction in space travel costs by 2027 is expected to catalyze significant growth across the aerospace, telecommunications, and robotics sectors. The aerospace robotics market, valued at approximately $2.9 billion in 2023, is projected to experience substantial expansion driven by technological advancements and increased competition, particularly from emerging space powers like China and India. The global space economy is set to escalate from $630 billion in 2023 to an estimated $1.8 trillion by 2035, fueled by rising satellite demand and the integration of advanced technologies like AI. This growth indicates a robust interconnection between technological innovation and market expansion, where advancements in space capabilities will likely permeate various sectors. From telecommunications to defense. 2. Technological advancements. Central to the projected growth is the role of automation and AI in enhancing manufacturing processes, thereby reducing operational costs. Technologies such as 3D printing and digital twins are pivotal in optimizing production, allowing for lightweight components that improve fuel efficiency and minimize emissions. For instance, AI tools streamline design and production processes, while digital twins enable real-time simulations for better decision-making and efficiency. The integration of these technologies not only reduces costs but also accelerates innovation cycles, allowing companies to adapt swiftly to market demands. As firms leverage these advancements, the aerospace and defense sectors are poised for transformational changes, leading to more sustainable and efficient practices. 3. Industry challenges. Despite optimistic growth projections, the aerospace sector faces significant challenges that could impede progress. Supply chain disruptions exacerbated by geopolitical tensions and pandemic-related complications pose persistent hurdles. Workforce shortages remain a critical issue, particularly as demand for production increases in light of rising military budgets and commercial air travel. Companies are compelled to extend the lifespan of existing aircraft due to delays in new aircraft production, further intensifying the demand for maintenance, repair, and overhaul (MRO) services. This scenario highlights the need for strategic investments in workforce development and supply chain resilience to mitigate risks and maintain production targets. 4. Timeline of expected developments. The timeline leading up to 2027 outlines critical milestones that will shape the aerospace landscape. In 2024, strong demand across aviation sectors is anticipated, although supply chain issues may limit production output. By 2025, the industry is expected to witness pivotal advancements in digital technologies and increased investments in automation, positioning it for a resurgence in aircraft production and defense systems. The culmination of these efforts in 2027 is projected to result in a significant reduction in space travel costs, fundamentally altering the dynamics of the aerospace industry. This timeline emphasizes the importance of continuous innovation and strategic investment to navigate challenges and capitalize on emerging opportunities. In summary, the projected 50% reduction in space travel costs by 2027 is a transformative development that will influence industry growth, technological advancements, and operational challenges. As organizations adapt to this evolving landscape, the interplay between innovation and resilience will be crucial for success in the aerospace, telecommunications, and defense sectors. Here are 3 famous historical cases that illustrate transformative impacts on industries due to significant reductions in costs and technological advancements. 1. The Industrial Revolution, 18th to 19th century. The Industrial Revolution marked a pivotal turning point in history, characterized by the transition from agrarian economies to industrialized and urbanized societies. Innovations such as the steam engine, mechanized textile manufacturing, and advancements in iron production drastically reduced the costs of goods and enhanced production efficiency. This transformation led to the rise of factories' mass production and significant changes in labor dynamics, ultimately reshaping economies and societies. The effects were far-reaching, influencing transportation, e.g. railways, manufacturing, and even social structures as urbanization increased and new labor laws were enacted in response to industrial working conditions. 2. The advent of commercial aviation, mid-20th century. The introduction of jet engines in the 1950s revolutionized air travel, drastically reducing costs and travel times. The Boeing 707, which first flew in 1957, made transcontinental and international flights more accessible and affordable, leading to a boom in commercial aviation. This transformation not only affected the airline industry but also had profound implications for tourism, international trade, and global connectivity. By making travel faster and more economical, it facilitated the rise of a globalized economy, allowing businesses to expand operations internationally and influencing cultural exchanges worldwide. 3. The digital revolution, late 20th century, present. The digital revolution, driven by advancements in computing and telecommunications, has led to significant reductions in the costs of information processing and communication. The proliferation of the internet, personal computers, and smartphones has transformed industries ranging from media to retail to education. Companies like Amazon and Netflix have disrupted traditional business models by leveraging digital platforms to reduce costs and enhance customer access to products and services. This transformation has not only reshaped consumer behavior but also led to the rise of new business models such as e-commerce and streaming services, fundamentally changing how goods and services are delivered and consumed in the modern economy. These historical cases exemplify how significant technological advancements and cost reductions can profoundly reshape industries and societal structures, much like the projected 50% reduction in space travel costs is expected to impact the aerospace, telecommunications, and defense industries by 2027. Future outlook: transformative effects of projected 50% reduction in space travel costs by 2027. The anticipated 50% reduction in space travel costs by 2027 is set to trigger a transformative wave across the aerospace, telecommunications, and defense industries. This significant change is expected to be driven by technological advancements, increased competition, and strategic investments in space exploration, particularly with the influence of emerging players like China and India. 1. Industry growth and economic impact. The aerospace, telecommunications, and robotics sectors are projected to grow by approximately 50% by 2027. The global space economy is projected to surge from $630 billion in 2023 to an estimated $1.8 trillion by 2035. This growth will largely stem from the increasing demand for satellite services, positioning systems, and AI technology applications. Commercial aviation: as air travel demand rebounds post-COVID, the global airline industry is expected to generate $1 trillion in revenue for the first time in 2025. Aircraft production rates are projected to rise despite ongoing supply chain challenges, with an estimated need for 44,000 new airplanes from 2024 to 2043. Defense spending: heightened geopolitical tensions are driving unprecedented demand for defense equipment, leading to a sustained increase in defense budgets globally. This increase will likely benefit manufacturers of military aircraft and systems. 2. Technological advancements driving change. Technological innovation will play a critical role in achieving the projected cost reductions in space travel. Automation and AI: the integration of AI and automation in manufacturing processes will enhance efficiency and reduce costs. For example, AI-driven design tools can streamline the creation of lightweight components, thereby improving fuel efficiency and reducing emissions. Additive manufacturing: the use of 3D printing technologies will enable the production of complex components at lower costs, accelerating the pace of innovation in aerospace manufacturing. This technology is particularly vital for creating reusable rockets and satellites. Digital twins and simulations. The adoption of digital twin technologies will allow companies to simulate and optimize production processes, enhancing operational efficiency and reducing development timelines for new space technologies. 3. Challenges and resilience in supply chains. Despite the optimistic growth projections, the aerospace sector faces significant challenges. Supply chain disruptions. Ongoing supply chain issues exacerbated by geopolitical tensions and pandemic-related disruptions continue to hinder production rates. Companies are expected to focus on diversifying their suppliers and investing in domestic supply chains to mitigate risks. Workforce shortages. A persistent shortage of skilled labor poses a challenge for the aerospace industry. Companies are likely to invest in workforce development programs, including apprenticeships and training initiatives, to address this gap. 4. Geopolitical considerations and competition. The competitive landscape for space exploration is rapidly evolving, with countries like China and India making substantial investments in their space capabilities. This competition is expected to spur innovation and drive down costs in the industry. Private sector involvement. The entry of private companies into the space sector is reshaping the dynamics of space travel. Companies like SpaceX and Blue Origin are not only reducing launch costs but also increasing the frequency and accessibility of space missions. Regulatory environment. As competition intensifies, governments may implement regulatory measures to encourage domestic investment in aerospace technologies, particularly in defense and national security sectors. 5. Sustainability and future innovations. As the aerospace industry grows, sustainability will be a key focus. Green technologies. There will be a continued push towards sustainable aviation technologies, including electric and hybrid aircraft. Investments in renewable energy sources and sustainable materials will be prioritized to reduce the environmental impact of air travel. Smart manufacturing. The integration of smart manufacturing technologies will optimize production processes, enhance sustainability, and reduce waste. This trend will be essential for companies aiming to meet increasing consumer demand for environmentally friendly products. Conclusion. The projected 50% reduction in space travel costs by 2027 is set to catalyze profound changes across the aerospace, telecommunications, and defense industries. While significant opportunities for growth and innovation lie ahead, the sector must navigate challenges related to supply chain resilience, workforce development, and geopolitical dynamics. Embracing technological advancements and focusing on sustainability will be crucial for capitalizing on the transformative potential of this new era in space exploration.